multiplying and dividing rational expressions. So based on basic mathematics, we know how to multiply or dividing fractions, such as we have 2 over 5 times 10 over 14, like that. Then you can actually simplify this 1 and 7, and then this and then 2, so become 2 over 7. Then based on this, do you see what I did? Yes, I found out the common factor between the numerator and denominator, and then we simplify before calculating it. Even we have maybe 4 over 15 divided by 8 over 5, in this case too, we switch that 4 over 15 multiply 5 over 8 first, and then of course you can multiply crossly first and then simplify, but another way, we can simplify, find the common factor. So this becomes 1, this becomes 2, this becomes 1, this becomes 3, so answer becomes 1 over 6, like that, right? So this skill we utilize the most for this section. Okay, then let's look at one example. So given question is 14 p squared times n over 2p n cubed multiply 6p cubed n squared over 7p n fourth. So like last time, I'm gonna recollect number term, p term, and n term all separately. Then this become 14, 6, 2, 7, and p square, p cube, and p, and then p, and n square, and n cube, and n fourth here. Okay, so from here we can simplify. Then it becomes 2 and 3, and there are total 5 and total 2 here, so we can rewrite this p5 over p2, which means p third. Now this is the n3 over n7, so becomes 1 over n fourth. So we can rewrite this 6 times p cubed times 1 over n fourth, so answer become 6p cubed over n fourth. Okay, what about this case? So 3 over x squared minus 2x multiply 2x minus 4 over x. Do you see the difference between this problem and the previous one? Yes, the previous one, everything is multiplying and dividing, or the numerator over denominator as a monomial. But this case, we have at least two binomial value here, which means it requires factoring first. So if you factor that, then become 3 over x minus 2 and 2x minus 2 over x here. So now, do you see any common factor? We can cancel out between the numerator and denominator. Yes, x minus 2. So, and then anything else? No, right? Then just multiply them. So it becomes 6 over x squared. That will be the answer for this question. Then let's do little bit harder one. Maybe I. Then it shows that y cubed minus 1 over y squared minus y minus 6 multiply y squared plus 5y plus 6 over y squared minus 1. So as you see, they are all binomial or trinomial, which means you have to factor in before simplifying. If you factor those all binomial and trinomial over to say polynomial, you will get y minus 1, y squared plus y plus 1, and y minus 3, y plus 2, and y plus 2, y plus 3 over y plus 1, and then y minus 1. Okay, do you see any common factor between numerator and the denominator? Yes, I see some as well. So this is gone and this is gone. Anything else? Nope. Therefore, the answer becomes y plus 3 times y squared plus y plus 1 over y minus 3 and then y plus 1. That is the answer for this question. Then what about the division case here? Such as 3c, then a squared minus b squared over a plus 3b divided by ab plus b squared over 2a plus 6b. So you can rewrite this first of all using the multiplication. Then a squared minus b squared over a plus 3b, and we switch the multiplication, then it becomes 2a plus 6b over ab plus b squared. Now you see everything is binomial, so you have to factor in. Then become a plus b, a minus b over, it's just a prime factor, so a plus 3b multiply 2a plus 3b, this become b, then a plus b. Okay, so cancel all the common factor, then the answer becomes 2a minus b over b. Okay.